Good morning. We're going to get right into the lesson today. Today's lesson is Algebra Saxon 2, lesson 17. We're talking about subscripted variables and angle relationships. We're talking about subscripted variables. A lot of times people look at those subscripted variables like we have right here, n or nd, and they get a little confused with them. We don't want that to happen. And so a lot of times you'll see these when we need to denote a special relationship between the main variable because there's going to be a number of something and a number of something. Our book, if you want to go back and read before 17.1, before that example problem, which is what we have right here on page 86, they'll explain a little bit about that. We're not going to do that necessarily right now. I'll give you the opportunity to read that on your own. But suffice it to say, something like this would mean the number of nickels plus the number of dimes equals 40. Now this necessarily may not be the monetary value, just the number of pieces that there were. So I had so many coins, I had some nickels, some dimes, and it would equal 40 different pieces. And so that's where we're going to use this relationship. But don't let it confuse you. We can think of NN and ND as just separate variables, like an X and a Y at this point. So I have NN plus ND equals 40. 5NN plus 10ND equals 250. So we're going to treat it the same way as we did other system of equations. And we're going to eliminate here. So jumping right into it, if we're eliminating, remember we're looking for, first off, something with the same number, which we don't have, 1 and 10, 1 and 5, and then something with opposite signs, positive, 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 positive. We don't have either of those. If you like substitution, you can do that. You can take an ND over here, change sides, change signs, NN equals 40 minus ND, and then plug it in right here. I personally like elimination, goes a little faster, I believe. So what I'm going to do, I'm going to multiply every term by -5. And what that's going to do is give me a -5 NN plus, I say plus, I should say minus, 5 ND equals a -200. Then I already have the 5 NN on the bottom, plus 10 ND equals 250. Add straight down, of course, these eliminate. I end up with 5 ND equals 50, because 250 minus 200. And then ND equals 10. And if ND is 10, we could easily plug it back into NN plus 10, because ND equals 40. Change sides, change signs. NN equals 30. And so we end up with our two answers right there for NN and ND. Now that one's a pretty easy one. Nothing difficult about that. The next one we're going to see here is about the same. It's not really difficult, but it has these subscripted variables as well. And you'll see it's RT, RMT, and RT and RT here. And these are usually going to denote a rate and time problem or a distance problem, because rate times time equals distance here. And this may be the rate of Matt and time of Matt plus the rate of Walter and time of Walter. And so those M's and W's may just denote a different person. So let's look and see how that's going to work too. Same basic principle as we would if they were just a single variable. But now we have a big long equation. Now when you're doing these, we talked about this in algebra before, but you have to look for your base equation. And this is going to be our base equation because it has most, if not all, the variables in it. And then from that base equation, we're going to substitute what we know. If Rm equals 40, we can stick that in here. And if Rw equals 60, we can stick that here. The one we don't know is kind of different, is Tm plus Tw equals 5. Because there's nothing in there Tm plus Tw, there's two separates. So what I'm going to do is I'm going to say Tm equals 5. Do you know where I'm going with this? Yeah, we take that Tw over here, change sides, change signs, minus Tw. So, that point on, I'm going to substitute all three of these into my base equation. Rm equals 40, I don't have any, well I do have a Tm, times 5 minus Tw, plus Rw is 60, and we're solving for Tw, Let's go ahead and do our multiplication, distributive property here. 200 minus 40 TW plus 60 TW equals 260. All right, so combine what we can here, the TWs, and I can take the same step earlier. I can take this 200 over here, change sides, change signs. So I have 20 TW because 60 minus 40 gives us 20. TW equals 60. You can divide by 20 on both sides to find TW. TW equals 3. Now, here's where it gets easy. If you're solving for Tm, because we know what Rm and Rw are, we just solved for TW. How do we find Tm? Well, remember Tm is 5 minus TW, or 5 minus 3, or just 2. So we have our answers of TW equals 3, Tm equals 2. Okay, so we're jumping over to the to the next part of the lesson, and that is example 17.3. That is going to be angle relationships. Now we've already talked about transversals. Remember what transversal is? It's a line that crosses two parallel lines. So this line right here is the transversal. And because it's a transversal, we know that there's angle relationships. We know that this angle is equal to this angle, equal to this angle, equal to this angle. But we also know that this angle is equal to this one, which is equal to this one, which is equal to this one. And so how do we make that work for us? Well, it's going to be a system of equations. Again, I can say that 5x minus 10y, again this is 17.3 if you're following along, is equal to 50, because this angle is equal to this angle. So this equals this. You see where I'm going with this? Then I could also say that 7x minus 2y is equal to 130. You may say, how in the world did you get the 130? Well, I know a straight angle from here all the way around is 180 degrees. This is 50, so it leaves 130 right there for us to assume. And now I have a system of equations that I can solve. So what am I going to do to solve this system of equation? Well, I'm going to, again, I'm going to get one of my variables to match numbers but opposite signs. I'm going to get rid of the y in this case, and so I'm going to multiply everything by 5. But the problem is, even if I multiply everything by 5, I still have the same sign, negative and negative. So what I have to do is multiply everything by negative 5. Or if you want to, just multiply everything by 5 and then change the signs once you get that done. So here's what I end up with. 5x minus 10y equals 50. Negative 35x plus 10y equals, well, this is the big one. What is 130 times 5? Well, we know it's going to be a negative number. 130 times 5, big one, is going to be 650. Okay, so here's what we have. 5 minus 35 is negative 30x. My y's cancel. 50 minus 650 equals negative 600. Now it gets kind of easy from here. If you get nervous with dividing big stuff like that, just remember, if a negative divided by a negative cancels those negatives. And if you say 600 divided by 30, it should make sense, but if it doesn't, just take away one of the zeros for each of them, and you have 60 divided by 3. X is going to be 20. And if x is 20, how does that help us? Well, we can plug it back into one of our equations, maybe this one up here. 5 times 20 minus 10y equals 50. And we could say 100 minus 10y equals 50. Get this 100 up here, change sides, change signs. Negative 10y equals negative 50. Divide by negative 10 on both sides. Y equals 5. And so that should maybe clear that up a little bit, and just recap what we talked about today. Our variables, our subscripted variables. Right now, just understand that this is just denoting what this variable is standing for. In this case, maybe nickels and dimes. In this case, it's a distance problem, rate times time, and who the rate, and who the time belonged to. And then on our angles and the relationships between angles, it simply means we're simply going back to what we studied with our transversals and how they are related angle per angle with transversals. As always, if you have any questions, let me know. I'll be glad to help you out with those.